So first question is, find the average velocity when the particle completes the circle of radius 1 meter in 10 seconds. So first of all, this is not motion in a straight line, it's moving on a circle, but the theory that we have discussed, it is relevant to this thing also. Okay, motion in 2 dimensions, 3 dimensions. Okay, these are very simple things. So find the average velocity when particle completes the circle of radius 1 meter in 10 seconds. So can you tell me the answer?
Zero.
It would be 0.
Zero.
Right? Because our particle starts from this point, let's call it A. The starting point is suppose A, and it completes a circle. Okay, so we are asked about the velocity. What is velocity? Velocity is
Displacement by time.
displacement by time. Okay, so when it covers one revolution, it comes back to same point. That means starting point and the end point, they are same. So there is no distance between start point and end point. So displacement is 0, and that's why the velocity is 0. Okay, so option D is the answer. So Sanjay, this is clear?
Yes, sir.
All right. So let's move on to the next question. Next question is similar. A runner starts from O. Runner starts from point O and goes to O, goes back to O, following the path O, Q, R, O. So he or she moves from this point to this point to this point to this point. Okay, O, Q, R, O in 1 hour. What is the net displacement and average speed? This is the question. Tell me.
Displacement 0.
Okay. And average speed? Is it 0?
No.
Everybody, is it 0? Average speed, is it 0?
No, sir.
No, sir.
Okay, so good. Average speed is not 0. Okay, so see, there is one option 0, 0. Okay, that's not the answer. So first one is 0, second one we need to find out. So how much is the distance covered? So he moves from here to here, and then from here to here, and then from this point to this point. Okay, so distance covered is r plus, this is 1/4 of circumference. Okay, this is the circumference of circle. Then this much distance is 1/4 of the circumference. Okay, so it is 2 pi r divided by 4 plus r. Okay, so I can say the distance covered is equal to r plus 2 pi r divided by 4 plus r. So that's equal to 2r plus pi r divided by 2. Okay, so that's equal to, now 2 plus pi by 2 r, we can say. Okay, so it's equal to, distance is equal to 2 plus pi by 2. So 2 plus 3.14 divided by 2 multiplied by r. Okay, so that's equal to 3.14 upon 2 will be how much? 1.57,
5.
right? So 2 plus 1.57 multiplied by how much is r? R is 1 kilometer. Okay, r is 1 kilometer. So multiplied by 1, this is distance covered. And what will be speed? So speed is, average speed is distance covered upon time. So d by t. So it is 2 plus 1.57, that is 3.57.
3.57.
So 3.57 upon 1, right? So 3.57 is the answer. So this was simple question. Next question. So next question is, a wheel completes 2000 revolutions to cover the distance 9.5 kilometers. Okay, to cover the 9.5 kilometer distance, then the diameter of wheel is. So can you tell me how to solve this? Okay, so I have got, let's suppose I have this wheel, okay, and this wheel moves on this road, okay. So this wheel moves by, it completes 2000 revolutions. Okay, this wheel completes 2000 revolutions and then it moves by some distance. How much is the distance? The distance covered is 9.5 kilometers. So my question to you is, how much would be the distance covered in one revolution? Distance covered on the road in one revolution will be 2 pi r.
Yes, sir.
Okay, so distance covered is equal to number of revolutions multiplied by 2 pi r. Okay, and then it's equal to 9.5 kilometers. Okay, so this is 2000 multiplied by 2 pi r equals to 9.5. And okay, some answers are in kilometers, some are in meters, and one is in centimeters. Okay, so 9.5 kilometers, let's keep it as it is. Okay, let's multiply by 10 raised to 3. Let's convert it in meters because we have got 2000 over here. So this 10 raised to 3 and this thing gets cancelled out. I mean, we can divide both sides by 10 raised to 3. So we are left with 2 times 2 pi r equals to 9.5. Okay, so 2 times pi multiplied by 2r equals to 9.5. Therefore, we get 2r is equal to 9.5 divided by 3.14 multiplied by 2. If I take this on other side, okay, pi multiplied by 2, I am taking on other side, so it goes in denominator. So this is 2r is equal to 9.5 divided by this thing. So we are asked about the diameter, that's why I kept 2r over here. So how much would be the diameter? 9.5 divided by 3 will be 3.14 will be around 3. Okay, 3 divided by 2 will be, it's equal to 1.5, right? So 1.5
Yes, sir.
meters is the answer. This is the diameter. Yes, no?
Yes, sir.
Yes, sir.
This was simple.
Yes, sir.
Yes, sir.
Understood everybody?
Yes, sir.
Okay,
Yes, sir.
let's move on to the next question. So next question is, a cyclist moving on a circular track of radius 40 meters completes half revolution in 40 seconds. Its average velocity is. So can you tell me what would be the average velocity of a cyclist who covers half revolution in 40 seconds?
2 meter per second.
Will be 2 meters per second. Right. Others? See, this cyclist is moving on a circle. Let's say cyclist starts from this point. Okay. So in half revolution, he will move to the diametrically opposite point. So how much is the displacement? Displacement is this much. Right. Displacement is this much. Okay. Which is equal to 2 times r. Right. So displacement is 2r. So what would be
Yes,
velocity? Velocity is 2r
2 meter per second.
divided by 40. Right, 2 meters per second. So 2 times 40 divided by 40. So 2 meters per second is the velocity. So again, this was simple.
yes, sir.
Yes, sir.
Okay.
Yes.
So sometimes these kind of questions can be asked. Okay. So this question is common, right? This is not from NEET, but it can be asked in NEET. Okay. So let's move on to the next problem. A car covers the first half of the distance between the two places at 40 kilometers per hour and another half at 60 kilometers per hour. The average speed of the car is. Okay, this is the question. So let's suppose the car moves from town A to town B, and there is another town at the center of the road joining A and B. So it covers this much distance. Okay, first half. So let's say total distance is S. So how much would be this much distance? S by 2. Okay, so this much distance is S by 2. Distance between A and C and B is S by 2. So it's given that V1, so speed of the car when it moves from A to C is 40 kilometers per hour, and when it moves from C to B it is 60 kilometers per hour. What would be the average speed? Will it be 50? Yes, no? V1 is 40 kilometers per hour and V2 is 60 kilometers per hour. Okay, how will you solve this? Just tell me the definition of average speed. It is
V, V is equals to S
Distance by
by
time.
right.
and average speed equals to distance upon total time.
Total distance divided by total time. Right. So we know the total distance. It is S, but we don't know about the total time. So we need to find total time. Right. So average speed is equal to total distance, which is S divided by total time. Okay. So total time. So this car takes, let's say, time t1 to move from point A to C and time t2 to move from point C to B. Okay. So I can say that for first distance, okay, V1 is equal to distance AC divided by T1, and from this I can write the T1 is equal to what? It is AC, which is S by 2 divided by V1. Okay, I will take V1 on this side, T1 on this side. So T1 equals to distance AC, which is S by 2 divided by the velocity, which is V1. Okay, and similarly I can write T2 is equal to what? CB divided by V2. Okay, so T2 is equal to remaining half distance, which is S by 2 divided by V2. And now my problem is solved. Okay, see, the average velocity is S divided by T1 plus T2. The total time is T1 plus T2. Okay, so that is equal to S divided by, what is T1? It is S upon 2V1, right? It is S by 2V1 upon V1. Okay, so this 2 is in denominator. You can take it in denominator. So it will be in multiple of V1. And plus I have T2, which is S by 2V2, S upon 2V2. And then you can cancel out S. Okay, you can take S common and cancel it out, right? So S gets cancelled, this gets cancelled, So what are you left with? And this 2, okay, we can't do anything about the 2. Anyways, so let's add a page. So we have V average is equal to 1 upon 2v1 plus 1 upon 2v2. Okay, so this is equal to, now we have to make its denominator same, right? So 1 upon, I can multiply by 2v2, I can multiply by v2 over here and v1 over here. Okay, so this thing I will multiply by v2 and this thing I will multiply by v1. So I will get 1 upon, sorry, v2 divided by 2v1 v2 plus, here I will get, if I multiply with v1, it will be v1 divided by 2v1 v2, v1 divided by 2v1 v2. And now denominator is same, you can take it common, right? You can write common denominator, and it is the denominator of denominator, so you can take that to numerator, right? So this is 2 times v1 v2 divided by v1 plus v2. Okay, so now we can substitute the values. We got this formula, we can substitute the values. So what are values? 40 and 60. So it is 2 times 40 multiplied by 60 divided by 40 plus 60 is 100. Okay, so this is 6 4s are 24 times 2 is 48. 48 kilometers per hour. This is the answer. Yes, no?
Yes, sir.
Yes, sir.
Okay, and this is from UK PMT. What is UK? United Kingdom? Uttarakhand. Right? This is the toughness of the question that you will get in NEET exam. Okay, this is the level of the question. So these questions, yeah, this question is okay. The first 2 questions that we saw, first 3 questions actually, they were very simple. So this is the kind of questions you can expect in NEET exam. Okay, so it will take lot of time, right?
Yes, sir.
So what will you do?
We have to memorize this formula.
Yeah, you can memorize this formula. Okay, so you can directly write. So instead of doing all this and substituting over here, you can directly write that V average is equal to, so if the total displacement, it is divided into 2 parts, then it will be equal to what? It will be equal to,
2v1.
yeah, it will be this thing 2v1 v2 divided by v1 plus v2, but it can be divided into 3 equal parts. Then what will you do?
2v1 v2 v3 upon v1
No, no,
plus
no,
v2
no,
plus
no,
v3.
no, no, no. Okay, see, then in that case there won't be this 2. Okay, you will not have 2 because it is divided in 3 parts. So in place of 2 you will have 3. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, if it is divided in 4 parts, then you will have 4.
4.
There will be 4 velocities. So where, okay, at what point you can generalize it? So this is the point, okay, which I guess I have written it here. So this is the point where you can generalize it. Okay, so let's generalize this. All right, so I will move it here and I will give you a general formula. So for n equal parts. Okay, that means the distance is divided, the total distance is divided into n parts. 1, 2, 3, 4, 5, 6. Okay, n parts. What will you do? Your formula for the average velocity, you can see over here, if you have two parts, it will be 1 upon, okay, 1 upon 2v1 plus 1 upon 2v2. Okay, I am taking
Yes, sir.
reciprocal of both sides, right? So a numerator will come to denominator, denominator will go to the numerator. Okay, so instead of writing VAV, I can write 1 upon VAV, it's equal to 1 upon, see what I'm doing, 1 upon nv1 plus 1 upon nv2 plus 1 upon nv3 plus so on and so forth. Okay, so most probably you will not need it beyond v3. Okay, but let's suppose you divide it in n parts. Okay, so this will be your generalized formula to find out average velocity. So got it? So I will write it
Yes, sir.
clearly. Okay, so if the distance covered is divided in n parts, and velocity for each part, velocity for the consecutive parts, I can say, sorry, is v1, v2, v3, so on and so forth. Okay, then the average velocity is this. All right, so everything is clear till now.
Yes, sir.
Yes, sir.
Okay,
Sir.
so let's move on to the next problem. A person traveling in a straight line moves with a constant velocity v1 for certain distance x, with constant velocity v2 for next equal distance. Then the average velocity v is given by the relation, and this is from the NEET, I guess 2020. So now we know that formula. So what is the formula? 1 upon average velocity is equal to, so now the total distance is s, it is divided in two parts, s by 2 and s by 2, right? So it's equal to 1 upon 2v1 plus 1 upon 2v2. Okay,
Yes, sir.
so this is equal to 1 by 2, you can take common. Is it similar to, it is exactly similar to last problem. Okay, so it is 2 times v1 v2 divided by v1 plus v2, right? So it is v2 plus v1, if you take 2 common, so v2 plus v1 divided by 2v1 v2, and therefore average velocity is 2 times v1 v2 divided by v1 plus v2. Okay, so we applied the formula, right? Is it clear,
Yes, sir.
everybody? Okay, so which is the answer?
Option B.
Option B is the answer. Okay, so they don't want to waste your time, so that's why they have written the answer like this. Okay, so you don't even have to do all this, just take this 2 on this side. So 2 upon the average velocity is 1 upon v1 plus 1 upon v2. So option B is your answer. Okay, so let's solve some problems based upon uniformly accelerated motion. So this first problem, a ball is thrown vertically downward with a velocity of 20 meters per second from the top of a tower. Okay, it hits the ground after some time with velocity 80 meters per second. The height of tower is. Now I want you to tell me the kinematic equation of motion that will solve this problem. This is from NEET 2020. You have final velocity, you have initial velocity, you have acceleration.
V is equal to U plus AT.
No. We want to find out
B
the
square
height.
equal to U square plus TBIS.
Right. Okay. So see, the ball is dropped from this height, it reaches the ground, and this is the height. It is released with some initial velocity u. It falls on the ground with some final velocity v, and it's moving downwards. Acceleration due to gravity is also downwards. Okay, so your acceleration is positive, right? The movement, sorry, the displacement and acceleration, they are in same direction. So you will take acceleration as positive. So this formula, v square equals to u square plus 2 times a multiplied by s, or we used vt square equals to v naught square plus 2 times a multiplied by s. Okay, so here s is equal to this height, and we are asked about the height, right? So we get, okay, we substitute a equals to what? G, and s equals to, sorry, s equals to h. Okay, so v square equals to u square plus 2 times g multiplied by h is what we get. Then we can take u square and 2g on the other side. So we get h is equal to v square, and this u square will become minus u square on other side, and 2g will go into the denominator. Okay, so 2gh is equal to v square minus u square, and I will move 2g also on other side, so it goes to the denominator. Okay, and it's given that g is equal to 10 meters per second squared. So what is v? It is 80 square minus 20 square divided by 2 times 10. So tell me, what would be the answer? You can take 10 common from these two, so it will be 10 square 100. So what are you left with? 8 square is 64 minus 2 square is 4 multiplied by 100, okay, divided by 10, 20 actually. Okay, so if you divide by 10, this 2 times 10, okay, so this you are left with 10 over here, okay, and then 10 by 2 is 5, or 64 minus 4 is 60, and 60 divided by 2 is 30, 30 multiplied by 10 is 300. So your answer is 300 meters, right?
Yes, sir.
Yes, sir. Sir, and when we take acceleration as negative, sir?
When the velocity and acceleration are in opposite direction. So let's say you throw the ball vertically upwards, okay, so velocity is upwards, the ball is moving upwards, and the acceleration is downwards, right? The earth is attracting that ball, so acceleration is downwards, velocity is upwards. So you will take, if you take velocity positive, acceleration would be negative.
Okay, sir.
Okay, so if acceleration is in same direction as that of velocity, you will take it as positive. If it is in opposite direction of velocity, you will take it as negative. Okay, simple convention. Let's move on to the next problem, and this is what I was saying. A stone falls freely under gravity. It covers distances of h1, h2, h3 in first 5 seconds, next 5 seconds, and next 5 seconds respectively. The relation between h1, h2, h3 is. So here we can apply Galileo's law of odd numbers. first 5 seconds, next 5 seconds, and next 5 seconds. What will be the ratio? So h1 is to h2 is to h3 is equal to what? 1 is to 3 is to 5. Right? This will be the ratio.
Yes, sir.
Using Galileo's law of odd numbers. Distances covered by a body in equal intervals of time. Which body? Which is performing uniformly accelerated motion. So those distances are in the ratio of 1 is to 3 is to 5 is to 7 and so on. Okay. But now what are we asked? The relation between h1, h2, h3 is, what is the relation between h1, h2 and h3? Okay. So now I can write, see, h1 is to h2 equals to what? Or I can write this as a ratio. Okay, by ratio I mean quotient. So h1 divided by h2 will be equal to 1 upon 3, and therefore I can say that I can take this h2 on the other side. So h1 is equal to h2 divided by 3, and similarly I can write that h1 upon h5 equals to what? 1 is to 5, right? It is 1 is to 5. So I can take this h5 on, sorry, it is h3, okay? h1 divided by h3, so I can write h1 upon h3 equals to what? h1 upon h3 is 1 divided by 5. So it is 1 upon 5. I can move h3 on the right hand side, it goes to the numerator. So h1 is equal to h3 divided by 5. This is what I get. Okay. So h1 is equal to h2 divided by 3, and it is h3 divided by 5. Simple. So this is the answer. Right?
Yes, sir.
Okay. So yes. So see, you have 1, 2, 3. Okay. Okay. No other option makes any sense, and I guess you will not be tempted to write any other answer because there is no 1, 3, 5 anywhere. Okay, right? So I was checking if
Yes, sir.
there is some option where h1 is equal to 3 times h2 is equal to 5 times h3. So this is definitely not correct. So I was checking whether there is any option like that. Okay. So yes, this is simple provided you know Galileo's law of odd numbers. Okay. Otherwise you can find it. Otherwise there it will take lot of time. If you don't know this law, it will take lot of time to solve these kind of questions. Okay, so let's move on to the next question. A boy standing at top of a tower of 20-meter height drops a stone. Okay, assuming g equals to 10 meters per second square, the velocity with which it hits the ground is. This is very simple. So you are given that boy drops a stone, so u is equal to 0. We don't know. We know the height of tower, it's 20. Okay, and g is given, which is 10 meters per second square. Tell me the kinematic equation. Which one?
V square is equal to 2as.
Yes, v square equals
Answer is
to,
40.
you found the answer also, u square plus 2as. Okay, and I want velocity only, and u is 0, so it is 2 times g multiplied by h. So 2 multiplied by 10 multiplied by h is how much? It is 20. So this is 400, and I want v only. This is v square. So I will take square root.
20.
It is 20 meters per second. This is the answer. Option B. Right. So simple. This is a neat problem. Okay. This is a lottery. Right.
Yes, sir.
Yes.
And there have been lots of questions on uniformly accelerated motion. Okay. So see, this is another question. A ball is dropped from a high rise platform at t equals to 0 from rest. After 6 seconds, another ball is thrown downwards from the same platform with the speed v. Two balls meet at t equals to 18 seconds. What is the value of v? Okay, so how to solve this? A ball is dropped from a high-rise platform at t equals to 0 starting from rest. After 6 seconds, another ball is thrown downwards from the same platform, okay, with speed v. The two balls meet at t equals to 18 seconds. What is the value of v? So this is simple. See, a ball is dropped, okay. So first ball, let's say for first ball you can write s1 is equal to, no, okay, second ball is dropped after 6 seconds. Okay, so can I say S1 is equal to ut plus half of at square? Okay, let's call it u1t plus half of g multiplied by t square.
Yes, sir.
Okay, so let's call this t1, and for second ball it is, the distance will be same. Okay, so distance covered will be same. It is u2 times t, but this time will be how much? So first ball is dropped and 6 seconds after that the second ball is dropped. Okay, so let's write it as t2. So u2 times t2 plus half of g multiplied by t2 square. So you can equate these two. Right, because distance covered by both the balls will be same if they are meeting at any time. Okay, so I can write that, okay, first ball is dropped, then it is just dropped. Okay, it has no initial velocity, and second ball is dropped with speed v. Okay, second ball is thrown with speed v. Okay, so u1 is equal to 0. So in this first case, okay, in equation 1, let's say u1 is 0, so this is just half of g multiplied by t1 square. Okay, so I can say half of g multiplied by t1 square is equal to u2 multiplied by t2, and u2 is what we have to find out, plus half of g multiplied by t2 square. And now we can substitute the values. So what are the values? Half of g is 10, t1 is how much? It is 18 seconds. Okay, starting from t equals to 0 to t equals to 18. So t is equal to 18 seconds. So 18 square is equal to u2 times t2. So u2 is v multiplied by t2. Now second ball is dropped after 6 seconds. So it is 18 minus 6. Okay,
12 seconds.
12 seconds. So v multiplied by 12 plus this is half of g. So it is half of 10, 5 multiplied by what? t2 square is 12 square. Right. And now this is very simple. So let's move this thing on the left hand side. So 5 we can take common. It is 18 square minus 12 square. Okay, let's add a page, or let's do the calculations over here. Okay, so it is what? 12 times, sorry. So 12 times v is equal to 5 multiplied by 18 square. Let me add a page. Oh, what was that? 5 multiplied by 12 square, no? 12 square. So I can write 12 times v is equal to 5 multiplied by 18 square minus 12 square. Okay, so do you know square of 18? 18?
324.
324. And 12?
144.
144. Okay, so this is 12 times v. So v is equal to 5 multiplied by 324 minus 144. So is it 180? I think it is 180.
Yes, sir.
Divided by 12.
Yes, sir.
So what is that? So 180 divided by 12. So we can divide by 6. So if I divide by 6, so this will be how much? 30. 30 divided by 2. Right? It will be 30 divided by 2. That's 15. 15 times 5 is 75.
75.
Okay, 75 meters per second must be its velocity. Yes, option A is the answer. So simple.
Yes, sir.
Yes, sir.
Okay, I'm going to leave some problems for you. Right? So I have
Okay,
lots
sir.
of problems. I'm going to leave some problems for you. Next problem. A particle starts its motion from rest under the action of constant force. If the distance covered in first 10 seconds is s1 and that covered in first 20 seconds is s2, then tell me what will be the ratio? Apply Galileo's law of odd numbers.
1:3. So,
Sanjay?
Yes, sir. 1:3.
Okay. See, Galileo's law of odd numbers says that distances covered, let's say, okay, in first 10 seconds, distance is covered. How do I write it? Okay, so distance covered in first 10 seconds. So from 0 to 10 seconds.
Sir, answer is second option, sir.
Okay, answer is second option. So you calculated it or you are just saying that answer is second?
Sir, calculated, sir.
Calculated, no? Yeah, that's correct. Okay, so distance covered in first 10 seconds. S1, okay, is to distance covered in next 10 seconds. So now this is, okay, distance covered in next 10 seconds. So let's write it as, okay, so s in time t1 is to s in time t2. It is equal to how much? It is 1:3. Okay, so s in time t1 is distance covered in first 10 seconds. S in time t2 is distance covered in next 10 seconds. Okay, and this ratio is 1:3. That means this s t2 is equal to 3 times s t1. But you want distance covered in time 20 seconds, that is t1 plus t2, right? So your t1 is equal to 10 seconds and this t2 is equal to 10 seconds, and you want distance covered in what? Distance covered in 20 seconds. This is s2. Okay, so s2 is equal to distance covered in first 10 seconds plus distance covered in next 10 seconds. So st1 plus st2, so that's equal to what? st1 plus 3 times st1, that is equal to 4 times st1 or 4 times s1, you can say. So this is the answer, option B. Okay,
yes, sir.
so reading the question properly, understanding the question is important. So sure, it is based upon Galileo's law of odd numbers, but there is a catch. So they are saying 20 seconds, not next 10 seconds. Okay, so it is first 20 seconds. That means distance covered in first 10 seconds plus distance covered in next 10 seconds. Total of that. Right? Simple?
Yes, sir.
Okay.
Yes, sir.
Let's see next question. A particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meters per second to 20 meters per second while passing through distance of 135 meters in t seconds. The value of t is. This is from NEET 2008, and very simple question. You tell me how to solve.
S equal to ut plus half at square.
Okay, you are given that it changes its velocity from 10 to 20 while passing through this much distance. So velocity is changing. Okay, initial velocity is given, final velocity is given, distance is given. That means you have to use which formula? S is equal to ut plus half at square. Is that the formula? Okay, first of all, you need to find out. See, if you use S is equal to u times t plus half of a times t square, you can use this formula. There is no issue, except for you don't know the acceleration. Do you know the acceleration? You don't know,
No, sir.
right? So you have to find out the acceleration first. So v square minus u square equals to 2 times a multiplied by s. So that means I want acceleration, which is v square minus u square divided by 2 times s, and it is 20 square minus 10 square divided by how much? So 20 square minus 10 square divided by 2 times 135. Okay, whatever it is. So it is a is equal to 20 square is 400 minus 10 square is 100. So 300 divided by, okay, divided by what? 2 times 135. Let's keep it as it is. Okay, and now you know the initial velocity, you know the final velocity, and you know the acceleration. You want time. So will you use this equation or will you use first equation? V equals to u plus at.
First equation.
First equation. You can use this one also because you know the displacement. But here square is involved, so you have to solve a quadratic equation. So this doesn't make any sense, right? If you can solve it simply, then there is no need to solve a quadratic equation. Okay, so v equals to u plus at. That means, okay, t is equal to, or acceleration here itself, I can write it as v minus u divided by t. Okay, so what is v and what is u? So it is 20 minus 10 divided by t, 300 divided by 2 multiplied by 135. All right, so this is 10, so you can cancel out this thing. So 1 will remain here with this thing. So 30 divided by 2 multiplied by 135, and therefore t is equal to what? It is 2 times 135 divided by 30. Okay, and here too you can cancel out this 2 with 30, 15 will remain. Okay, 2 ones are and 2 15s are, or 15 twos are. So 135 divided by 15 is 9. 9 seconds is the answer.
Yes, sir.
Okay, so this is simple, slightly lengthy.
Yes,
Yes,
sir.
sir.
Okay, it is slightly lengthy, but you should attempt this kind of problems. Okay, this doesn't take much time, right? This is short. Okay, 4 marks. All right, so let's move on to the next question. The distance traveled by a particle starting from rest and moving with acceleration of 4 by 3 meters per second square in third second is. distance covered traveled by a particle starting from rest and moving with acceleration of 4 by 3 in third second is. So what do we have to do here?
S is equal to ut plus of at square.
Okay, let's use S equals to
U
ut
is equal to 0.
half at square. Okay, u is equal to 0, that's good. So it is just half of at square. Then shall I put a and t equals to 3 seconds? Yes, no? Okay, see, this is simple. They are asking distance covered in third second. Okay, so definitely you are hesitating because you know that if you put a, which is 4 by 3, and t equals to 3 seconds, then you will get distance covered in first 3 seconds, right? You will not get distance covered in third second. So what will you do to find out that? So let's say the body starts from here, okay, and in 3 seconds it moves till here. So this is, let's say, distance covered in first second, okay. So distance covered till second is this much, s2, and distance covered till third second is this total distance, okay. So what will be distance covered in third second? It will be this much distance, which is s3 minus s2. So distance covered in 3 seconds minus distance covered in 2 seconds will give you distance covered in third second, right?
Yes, sir.
Right, Sanjay?
Yes, sir.
Okay. So you can write that s3 minus s2 is what you have to find out, and that is equal to half of a multiplied by t3 square, let's call it t3, minus half of a multiplied by t2 square, okay. So that is half of 4 by 3, and I will take that common, okay. Half a I am taking common. It is t3 square minus t2 square, which is what, 3 square minus 2 square, okay. So this is equal to 4 by 2 is 2, 2 by 3 multiplied by 3 square is 9, 4 square is, sorry, 2 square is 4. So 9 minus 4 gives me 5. So 5 multiplied by 2 by 3. So it is 10 by 3. So 10 by 3 meters is the answer. Yes, option A is the answer. Simple.
Yes, sir.
Yes, sir.
Okay. So let's solve another question. Two bodies, A of mass 1 kg and B of mass 3 kg, are dropped from heights of 16 meters and 25 meters respectively. Okay, one is dropped from 16 meters, another one is dropped from 25 meters. The ratio of time taken by them to reach the ground is, this is simple. So does the velocity or acceleration due to gravity, does it depend on the mass?
No,
No, sir.
sir.
They will experience same amount of acceleration, right? Which is 9.8
Yes, sir.
meters per second square, and we'll take it as 10. Okay, we'll take it as 10 approximately. So the ratio of time taken by them to reach the ground. Okay, so first one is dropped from the height of 16 meters. So we know the h1, okay, is 16 meter. It is just released from that height. Okay, it is not thrown with any velocity. It is half of g multiplied by t1 square, and h2 is equal to half of g multiplied by t2 square. Okay, so you can take the ratio of these two. So this h1 upon h2 will give me t1 by t2 square, and then I will take square root on both sides. So I will get t1 by t2, t1 divided by t2, square root of h1 upon h2, and that is 16 divided by 25. So it is
4 by 5.
4 by 5. 4 by 5 is the answer. Okay, simple.
Yes, sir.
Okay. So if you
Yes, sir.
remember a formula over here, what is the formula? So let's say time taken by an object which is released, which is under free fall, which is released freely under gravity, okay, to reach on the earth is t. Then you can write the height is equal to what? Half of g multiplied by t square. Okay, so you take that half and g on the other side, so you will get t square is equal to 2 times h divided by g, and then if you take square root of that, you will get t equals to what? Square root of 2h divided by g. Okay, so if you remember this
Yes, sir.
formula, it will be simpler to solve. Okay, so time taken by a body under free fall to reach the ground, it is t. It's given by what? Square root of 2h upon g. So if you know this formula, t1 by t2 is ratio of what? Square root of h1 by h2 directly. Okay, because g and g will get cancelled out. So t is directly proportional to square root of h, and if you take the ratio, t1 by t2 will be just equal to what? Square root of h1 by h2. So please remember the formula. And even if you, this is very handy formula to memorize, but even if you don't remember, you can solve this very easily. Okay, simple question.
Yes, sir.
Yes, sir.
Okay, let's move on to the next question. A ball is thrown vertically upward. It has speed of 10 meters per second when it has reached one half of its maximum height. Okay, speed is 10 meters per second when it reaches one half of the maximum height. How high does the ball rise? This is the question. So the ball reaches this height and it has got 10 meters per second speed. Okay, so ball is still moving upwards, vertically upwards. So this much distance they are saying is s by 2. Okay, so ball reaches some more distance s by 2 and its speed becomes 0. Okay, 0 meters per second at that final height. And now we can use this formula. So v square equals to u square plus 2 times a multiplied by s. So which in this case is s by 2, right? So final speed over here is 0. Initial speed, since ball is moving upwards from this height, okay, it is 10 meters per second, and acceleration is minus 10. So now we get 0 equals to 10 square minus 2 times 10 multiplied by s by 2. So this thing gets cancelled, 2 and 2 gets cancelled. Okay, so 10 times s is equal to 10 square, and therefore s is equal to 100 divided by 10, which is 10 meters. Okay, which of the following curve does not represent motion in one dimension? So option A is like this. This is velocity versus time graph. Option B, velocity versus time graph, which looks like this. Option C is like this, and this is option D. All right. So this is a simple question, and the answer is option B. How? So if you take some time, let's say for this time, let's call it something. Okay, suppose this is t1. You draw a perpendicular on velocity versus time graph. So it meets at these 2 points. So what does that mean? This object whose velocity versus time graph is represented by this curve, it has 2 velocities. Okay, this velocity and this velocity at this time. Okay, so v1, v2. So my question to you is, can an object have 2 velocities at the same time? The answer is no, right? So that's why this velocity versus time graph is not correct. So it cannot represent one-dimensional motion, or for that matter any kind of motion. Okay, so the answer is option B, right? Next question. The displacement time graph of moving particle is shown below. The instantaneous velocity of the particle is negative at a point. So we have seen what is instantaneous velocity. So at any time, draw a tangent to the position versus time graph, and slope of that tangent will give you the instantaneous velocity. So we have these points, okay, these 4 points. So let's draw tangents at these 4 points. So 1, 2, 3 and 4. So you can see here this tangent is slanted upwards, that means the velocity is positive. This one is horizontal, that means at this point the velocity is 0. This one is slanted downwards, so at this point the velocity is negative, right? And that is what is asked in the question. So our answer is point E. Okay, this one is slanted upwards, so here also velocity is positive. Okay, so answer is point E. So E is in option A. So option A is the answer. Okay, simple. Next question. A particle shows distance time curve as given in this figure. The maximum instantaneous velocity of a particle is around the point. Which point? So again, let's draw tangents. So let's suppose these are the points 1, 2, 3, 4. Okay, so now let's draw tangents at these points. Okay, so for me, this tangent has the maximum slope. Okay, the point. Okay, for me, for my eyes, you can check this. Okay, this one has the maximum slope. So the answer would be point C. Okay, and it is option D. So option D is the answer. Simple. Next question. Next question is, two cars P and Q start from a point at the same time in straight line, and their positions are represented by xp of t is at plus bt square, and xq of t is ft minus t square. At what time do the cars have same velocity? At what time they will have same velocity? So we know what is velocity. Velocity is derivative of position with respect to time. So v of p is equal to v of q. Okay, that is derivative of xp with respect to t is derivative of at plus bt square is equal to derivative of ft minus t square. So now let's take the derivatives. So if you take derivative of this one, so a is a constant, it will go out, and it is dt by dt. So dt by dt is 1. Okay, so we have a plus derivative of bt square, so b we can take out, and derivative of t square with respect to t. What's that? So we have this rule, derivative of t raised to n with respect to t is n t raised to n minus 1. Okay, so here n is equal to 2, right? N is equal to 2. So the derivative will be what? 2 times t raised to, okay, n is equal to 2. So 2 times t raised to 2 minus 1. 2 minus 1 is 1. Okay, so that is t. So 2t, and it's equal to, similarly on right hand side, I can say it is f minus 2t. Okay, and then you can take this 2t on left hand side. So you get b times 2t plus 2t is equal to f minus a, and then you can take t common on left hand side. So what's left? It is 2b plus 2, and take that on right hand side. So t is equal to f minus a divided by 2b plus 2. This is the answer. So option D is the answer. Okay, if you take 2 common, it is b plus 1 or 1 plus b. Okay, so this is the answer. Next question. If the velocity of a particle is v equals to at plus bt square, where a and b are constants, then the distance traveled by it between 1 second and 2 seconds is. So we know what is distance traveled. It is area under velocity versus time curve, and mathematically it is the integral of velocity, okay, from a particular time to a particular time. Okay, so from initial to final time. So velocity is at plus bt square. You can write this as the derivative of position with respect to time is at plus bt square, and then you can write it in differential form. So I will write dx is equal to at plus bt square dt. Okay, you can say you are multiplying with dt on both sides, and then you take integral from 1 to 2. So time is changing from 1 second to 2 seconds. Okay, so position is changing, suppose from x1 to x2. So integral of dx will give you change in position. Okay, integral of dx is x. You put the upper limit, so x from x1 to x2, it's equal to this integral. So here a you can take outside, it is integral of p dt from 1 to 2, plus b you can take outside, it is integral of p square dt from 1 to 2. Okay, so here I have separated, okay, these two terms at and bt square. So it is integral of this thing dt plus integral of this thing bt square dt from initial to final limit 1 to 2. Okay, so this one. So now what do we have to do? So here it's x, substitute the upper limit, which is x2, minus the lower limit. Okay, whatever you get, you substitute upper limit, which is x2, minus you substitute lower limit in the same thing, same function. Okay, so it is x2 minus x1, and it's equal to a multiplied by, what is the integral of t dt? So we have this rule, this formula. So integral of t raised to n dt, okay, from some limits, okay, it is equal to t raised to n plus 1 divided by n plus 1. Here n is equal to 1. Okay, it is t means it's t raised to 1. So its integral will be t raised to 2 divided by 2. T raised to 1 plus 1, 2 divided by 1 plus 1. Okay, because n is equal to 1. So t raised to 2 divided by 2 from 1 to 2, plus here you have t raised to 2. Its integral will be t raised to 3 divided by 3. T raised to 2 plus 1 upon 2 plus 1 from 1 to 2. And now you have to substitute the limits. So it is equal to, what is equal to x2 minus x1. The displacement is equal to a times this t square upon 2. 2 you can take out. So a by 2. So it is 2 square minus 1 square. So 1 square is 1, plus b by 3. Okay, so 3 you have taken out. It is t cube divided, sorry, t cube, which is 2 cube. 2 cube minus 1 cube is 1. Okay, so from here you get 4 minus 1, that's 3. 3 by 2 a, and from here you get 8 minus 1, that's 7. 7 by 3 b. So 3 by 2 a plus 7 by 3 b is the answer. So option A is the answer. Okay, the x in meter of a particle, so x is position of mass m in kg moving in one dimension under the action of a force. Okay, so this particle is moving in one dimension, it's under the action of some force, is related to time in second by t equals to this equation. Okay, square root of x plus 3. The position of particle when its velocity is 0 will be. So this is the question. Okay, so first of all we have to convert this relation. So t is equal to square root of x plus 3 can be written as square root of x is equal to t minus 3, and then we can take square on both sides. So we get x is equal to square of t minus 3. Okay, after that we can find out its velocity. So in question they are asking when velocity is 0. Okay, so velocity is derivative of position with respect to time, which is derivative of position with respect to time, and it's given at some time it's equal to 0. But first of all, let's find out the derivative. So you can take derivative of this directly, or you can expand it. So it will be t square minus 60 plus 9, okay, and derivative of that. So what is derivative of this thing? So it is equal to derivative of t square with respect to t is 2t. 2t minus, you have derivative of this thing, so minus 6. Okay, minus 6 you have taken out, dt by dt is 1. So 2t minus 6, and it's given at some time this is equal to 0. So then, so 2t minus 6 is equal to 0. That means 2t is equal to 6 and t equals to 3 seconds. And you are asked what is the position at this time. So put t equals to 3 seconds here. Okay, you got this formula for x. So put t equals to 3 here. So what do you get? So 3 minus 3 is 0. Okay, so the answer is 0. So answer is option B, 0 meters. Okay, next question. A particle moves along a straight line OX at a time t in seconds. The distance x in meters of a particle from O is given by x is equal to 40 plus 12t minus t cube. How long would the particle travel before coming to rest? And the options are 16 meters, 24 meters, okay, 40 meters and 56 meters. Okay, so object is coming to rest, right? Then that means its velocity will be equal to what? It will be equal to 0. So we have to find out velocity. Okay, so we know velocity is dx by dt. So it is equal to d by dt of 40 plus 12t minus t cube, and it's equal to the derivative of 40 with respect to t is 0, right? Derivative of a constant is 0. Constant does not change with respect to time. Then 12 you can take out. Then you have derivative of t with respect to t, which is 1. So it's 12 minus derivative of t cube. So we have this formula, t raised to n, derivative of that with respect to t is equal to what? N, t raised to n minus 1. So here n is equal to 3. So substitute n equals to 3. We have 3 multiplied by t raised to 3 minus 1. 3 minus 1 is 2. Okay. So 3t square. So 12 minus 3t square. And this velocity is equal to what? So it is equal to 0. We have to find its position, the change in position from the beginning at t equals to 0 to t equals to when the velocity becomes 0. Okay, so the velocity is equal to 0. That means 3t square is equal to 12 and t square is equal to 12 divided by 3, which is 4. So t equals to 2 seconds. Okay, so how do we find the change in position? So it is final position minus the initial position. So we have got the formula, sorry, the time, okay, and the formula for position. So we can say x1 is equal to, okay, I can say x1 is equal to 40 plus 12 times 0, because initial time is 0, minus 0 cube, okay, so that is 40, and x2 is equal to 40 plus 12 times 2, because the time when the velocity becomes 0 is 2 seconds. So 12 times 2 minus 2 cube. So this is equal to, okay, 40 plus 12 twos are 24 minus 2 cube is 8. Okay, so 24 minus 8 is 16. So 40 plus 16, 56. Right? So 56. This is x2. So what is displacement? How much is the distance covered? It is x2 minus x1. So 56 minus 40, that is 16. So 16 meters. 16 meters is the answer. Option A is the answer. Next question. The position x of a particle with respect to time t along x-axis is given by x is equal to 9t square minus t cube, where x is in meters and t in seconds. What will be the position of this particle? What will be the position of this particle when it achieves maximum speed along positive x direction? So when it achieves maximum speed, okay, so this is the question. So now what will happen when it achieves the maximum speed? The acceleration will be 0, right? Okay, it has achieved the maximum speed. So you know, till the time there is some positive acceleration, what will happen? The speed will keep on increasing. So only when the acceleration becomes 0, the speed will stop increasing, right? There will be no change in speed if acceleration is 0. So when the particle achieves maximum speed, its acceleration will be equal to 0. Okay, so we have to find at what time the acceleration becomes 0. So we are given x is equal to 9t square minus t cube. So if we take its derivative, okay, so v is equal to dx by dt, we know it's equal to d by dt of this thing 9t square minus t cube. So let's take the derivative. I will write it directly because we have taken derivatives like this before. So derivative of t square is 2 times t minus derivative of t cube is 3t square. Okay, so it is 18t minus 3t square. This is your velocity. And what will be acceleration? So acceleration is change in velocity with respect to time, dv by dt. So it is d by dt of this thing 18t minus 3t square. So if you take the derivative, it is 18 minus 6t. Okay, so 3 times derivative of t square. Derivative of t square is 2. Okay, 2t. So 3 times 2t is 60. So 18 minus 60. This is your acceleration. And the acceleration is equal to 0. That means 6 times t is equal to 18. Okay, if I take this 6 times t on the other side, because acceleration is 0, so 6 times t is equal to 18. That means t is equal to what? 18 divided by 6. So it is 3 seconds. Okay, and the question is, what will be its position when it achieves the maximum speed? So we have to find the position at this time. So x is equal to 9 times p square, so 9 times 3 square minus 3 cube. So it is 3 square is 9, 9 times 9 is 81, 81 minus sorry, it is 3 cube, so it is 27. Okay, so the answer would be 54, right? So 54 meters is the answer. Okay, got it? Simple. Next question. A particle of unit mass undergoes one-dimensional motion such that its velocity varies according to this equation, where beta and n, this beta and this n are constants and x is the position of the particle. The acceleration of the particle as a function of x is given by, what would be the acceleration as a function of x? This is the question. So we are given velocity in terms of position, not in terms of time. And we are asked the acceleration as a function of x. So let's try to solve this. So you have velocity v of x is equal to beta x raised to minus 2n. And if you take its derivative d by dt of v with respect to time, you get d by dt of this thing with respect to time. But this is function of x. So that means you cannot directly take its derivative with respect to time. So what do you need to do? You need to use the chain rule. Okay, so if you don't know what is the chain rule, I will multiply and divide by dx. So d by dx of this thing beta x raised to minus 2n. So I have divided by dx. I will multiply by dx. So dx by dt. Okay. So now beta you can take out. It is derivative of x raised to 2n with respect to x. And we know the formula for that. So we get acceleration equals to beta is out. So minus 2n multiplied by x raised to minus 2n minus 1. Okay. So here the power is minus 2n. So it comes in multiplication. Minus 2n multiplied by x raised to power gets reduced by 1. Minus 2n minus 1. Okay. Multiplied by dx by dt. What is dx by dt? Dx by dt is velocity. Okay. And then we want it in terms of position only. So we know the velocity in terms of position is this. So let's substitute that back here. So we get it is equal to minus 2 times n beta x raised to minus 2n minus 1 multiplied by what is velocity? It is beta multiplied by x raised to minus 2n. So this beta times beta gives me beta square. Okay, so acceleration is minus 2n beta square multiplied by x raised to minus 2n. Minus 2n is minus 4n minus 1. Minus 4n minus 1. So minus 4n minus 1. This is the answer. Minus 2n beta square x raised to minus 4n minus 1. So option D is the answer. Okay, simple question, right? Provided you know the chain rule. Okay, so then let's see this question. A particle moves a distance x in time t according to the equation. This is the equation. The acceleration of the particle is proportional to. Okay, so let's find out. So first of all, let's find out velocity. So dx by dt is equal to, this is t plus 5 raised to minus 1. So d by dt of that. So it is minus 1. Okay, the power will come in multiplication. Minus 1 multiplied by t plus 5 raised to minus 1 minus 1. That's minus 2. Okay, so what did I do? So it's d by dt of position. Velocity is dx by dt. And so this is my velocity. So acceleration is dv by dt. So it is equal to, now this minus 1 is there and you have to take derivative of this term. So it is minus 2 multiplied by t plus 5 raised to minus 3. Okay. So it is 2 times t plus 5 raised to minus 3. And the question is, the acceleration is proportional to which of these things? So is it velocity raised to 3 by 2 or distance square or distance raised to minus 2 or velocity raised to 2 by 3? So let's check. So first one, let us check, is it velocity raised to 3 by 2? So we have acceleration as t plus 5. It's proportional to t plus 5 raised to minus 3 and velocity is proportional to t plus 5 raised to minus 2. So let us adjust t plus 5 raised to minus 2 here. How can we do that? So I can write this as, this is 2 times t plus 5 raised to minus 2, okay, raised to minus 3 divided by 2, right? So I am multiplying and dividing this power with 2, okay, with minus 2 actually. Or I can take this minus sign inside, okay, because we already have minus 3. So I will take minus sign inside. Okay, so I'm multiplying and dividing with 2. Okay, so see what you get. This is directly proportional to velocity, or in fact if I write this as minus 1 and here minus 1 negative sign, it will be velocity only. So this can be written as, so this is equal to, acceleration is equal to, what do I get? I get it as minus 2 multiplied by v raised to 3 by 2. Okay, so if I multiply this one and this one with -1, it is -1 t plus 5 raised to -2 is your velocity, raised to 3/2 gives you acceleration. That means the acceleration is directly proportional to v raised to 3/2. Option A itself. We don't need to check other options. So this is the answer. So I hope you understood how to solve the questions based upon derivatives and integrals from motion in a straight line. Keep solving questions. This is it for this lecture. Thanks for watching. See you in the next lecture.